Hello everybody, welcome to the second part of our series. So in this video, we're going to run our application locally using Docker. Now, before proceeding, I expect you to have a basic understanding of how virtual machines work. It's crucial for us to have a grasp on the basics of virtual machines in order for us to understand how Docker works. So let's find out more about Docker. So what is Docker? Docker is a tool that packages up software or tools that you use in your application, such as Node, MongoDB, Nginx, into separate parts called containers that resemble virtual machines. So for example, if you get Node, MongoDB, or Nginx from Docker, they're going to behave as if they are inside separate virtual machines that you can actually go into. You can go inside of them using the docker exec command, the docker exec command. Unlike virtual machines that have their own operating system, Docker containers don't have an actual separate operating system, so they are very lightweight and they don't use up as much space and CPU as virtual machines. This means that booting up your application takes significantly less time with Docker. There's another advantage that Docker containers have over virtual machines that don't use Docker. Virtual machines have a fixed amount of space, and if the app that is being hosted on that virtual machine doesn't take up all of that space, the extra gigabytes can't be used for another virtual machine because it was only allocated for that virtual machine. With Docker, however, we're actually able to use that extra memory to launch another container. So we don't have memory going to waste. So how do we actually use Docker? Well, you just install Docker onto your machine and then pull the images of each of the tools that you want to use from the Docker Hub repo, which is similar to pulling code from GitHub. Only here, you're pulling an actual tool that your application runs on. And later on, you put these images into a network so that they can actually communicate with each other when they're containerized. One of the nice things about Docker is that it solves a problem that developers often faced back in the day before containers came along. Having different versions of the software and dependencies that our applications run on can sometimes cause the application to not compile. For example, when using an older version of Node on a newer version of Ubuntu, running npm install commands sometimes doesn't work depending on what you're trying to install. With Docker, everyone pulls the Node image without having to worry about if their version is compatible with everyone else's, because they're all getting it from the Docker Hub repo. So there are two main things that I want to focus on, and they are the Docker file and the Docker Compose file. So in our application, we have two Docker files, one for our client and one for our server. So let's check out the Docker file for our client. For now, let's pretend that the Docker file is a script and that our image is a virtual machine. Using the Docker file, we give directions on what Docker should do with our image when it's being pulled. So what we're doing is getting an image from the Docker Hub repo, and it's a Node image. And we're going to call it builder, and that's going to come into play later on when we work with Nginx. And we're going to make a working directory, and this is basically the directory that we're operating from. And we're going to take our package.json file over here, and this file pretty much has all the dependencies that our client is going to be running on, or our front end is going to be running on. And we're going to copy it over into our working directory, and then we're going to say npm install so we can install all the dependencies. And then after that, we're going to copy every single thing from our client directory, and we're going to copy it over into our working directory. Now, because we are using Nginx, we need to make a build folder. The build directory contains the files our front end depends on when our app is running on a virtual machine. And then we are also going to get Nginx from the Docker Hub repo. Nginx is basically the tool that we're going to use to handle our routes in our application. The routes in our application are actually handled inside the config file. The Nginx image comes with a configuration file called default.conf, and it's located inside the image of Nginx. And remember, Nginx here, we can treat it as if it's located inside a virtual machine, because we're saying that our images are going to be pretend virtual machines. And in there is a file directory called /etc/nginx/conf.d, and the default.conf is a configuration file that Nginx comes with automatically. Now we want to get rid of this default.conf file and replace it with our own configuration file because it has the rules of the routing or the routing rules based on our preferences and what we tell Nginx to do. So that file is located in our local application, in our application directory, inside the client folder, inside the Nginx directory, and it's called default.conf. So for us, it's going to be located inside ./nginx/default.conf. And we're going to take that file and copy it into our image of Nginx so that we can replace the configuration file that comes with Nginx. So let's check out what this file really does. So anything going to API 1 is going to go to the API. So this location block handles the routes that are going to the back end, and it's going to send it to API at port 5000. An API is just a name for our back end. Anything other than that is going to be handled by this location block, which is going to read from the index file from the build file that we had produced earlier. And if it is a route that's not recognized, it's going to give a 404 error. And lastly, in line 20, we're going to take the build folder that we created in line 10 from the earlier part of this process that we called builder, and we're going to copy it over into the directory /user/share/nginx/html. So now that we've seen the Docker file for the client, let's take a look at the Docker file for the server. Here we're just installing all of our dependencies and copying everything in our server directory over to our working directory. And then we're going to say npm start to actually start our server. So now that we have our images ready, we need to containerize them. In other words, get them up and running. So the next thing we're going to look at is the Docker compose file. Now, as you can see, we have different images here. We have a client image, an API image, MongoDB image, and an Nginx image. And over here, we set up the network in order for our containers to communicate with each other. So basically, what we're doing is specifying the name of the image, where the Docker file is located, and what port we want to run this image on. So here we're specifying the port 3000 for Docker and port 3000 for our machine that is running Docker. And then here we specify the network that this image belongs to, the network that this container belongs to. For our API, we're doing the same thing, only over here we have a MongoDB app as an environment variable. And this is the connection string that we're using to connect to the image of MongoDB that we're getting over here. For MongoDB, we're going to be going on port 27017, and for Nginx, we have port 80. Now, technically, we don't need a Docker compose file. We could write out everything here on the command line every time we want to run our containers, but that's not efficient. So without further ado, let's actually run this application using Docker. I'm going to run git bash, and I'm going to go inside of the directory for my application. We're going to say docker compose up. So the first thing it's going to do is it's going to pull all the images that we're going to be using for our application. So because my computer is running so many different programs, that took a couple of minutes, and now I think the application is ready. So let's go to localhost port 80. And remember, our Nginx is running on port 80, and we're using Nginx this time, not port 3000. And there is our app. Now, it says nothing to display because this is a fresh database. There's nothing inside of it. So let's try it out and see if we can put some dummy data inside of it. Okay, let's refresh the page. Okay, and our application is running locally using Docker. Okay, so that was the goal of this video, and now it's time to take this application down and start cleaning up. So let's go and say Control-C. Okay, so let's see the containers that we have right now. Docker PS. Now we don't have any running containers because we just took our application down. But if we want to see all the containers that we have, including containers that are stopped and not running, we say docker ps-a. Okay, so we have all the containers that we were discussing earlier. We have one for the API, Mongo, Nginx, and client. So let's see our images, docker images. These three on the bottom are from a long time ago, so it doesn't apply here. And as you can see here, they're a couple weeks old, so these aren't images that we were working on today. Our images are Mongo, client, API, and Nginx. So what we want to do is get rid of all these images. So let's go and say docker image, not images, rm, and we're going to remove using the image ID. So we're going to say C157C0, and we only need to type in the first three digits, or the first three characters. Now these two have the same image ID because remember we created Nginx right after we created our client image, and we created them using the same Docker file, so they have the same image ID. And then we have Mongo, DFD. So now what we have to do is we have to remove them by force. So let's write the same command, and we're going to say .f. Okay, let's see if they are still there. Okay, they're no longer there. And that is all I wanted to show you for this video. Stay tuned for the last part of our series where we deploy our application and run it in the cloud on the EC2 instance using Docker.